Hello everyone, welcome to my YouTube channel. This is our part 2 of Amoled graphics and display circuit. I've already made part 1, so if you have not watched out but the part 1 of this video, kindly go and watch it out so that you will understand part 2. Okay, I'm not going to explain much in this part 2 because I have taken time to explain everything you need to know, okay, in part 1. So make sure you watch out part 1. Okay, so this part 2, I'm going to show you how to troubleshoot it one after the other using schematics. I'm going to tell you the step-by-step process of troubleshooting. If they bring a phone to you, the first thing you have to check is the screen. Okay, I told us that in this type of display that there is no light, there's no separate light. I see that the light and the graphics are meshed together. So after testing the screen, you discover that the phone is not still displaying but it's on in either with your DC supply, or you are hearing a vibration when you turn it on. So now the first thing you will check after your screen, after you've tested another screen and it's not still displaying, the first thing you will check is your MIPI lines. Okay, now let me show us our display IC. These are our hardware solutions. Okay, so this is our display IC, and these are the 3 colors that you see around this display IC. Okay, so this is the main display IC. Okay, so the first line you will test is these MIPI lines. They're usually 10 in numbers. Okay, so we have four MIPI lines here. Okay, 1 2 3 4. Okay, so now on this other side you will see 6 lines, six MIPI lines here. So if you add it with this 4, it's going to be 10. 2 3 4 5 6. So 6 plus 4 it will give you 10. So MIPI lines are 10 in numbers. Okay, so these are the lines that you will test. Okay, so when you open your hardware solution, you will go to your display connector. Okay, your display connector, but there are other lines like this Otacon detect PCD interrupt line, VREC. These are voltage line. I will take time to explain these lines using our schematics. We have here LCD enabling line, display tearing effect. We have here reset N and VDD. As 3 volts, 3.0 volts. Okay, so I will explain these lines so that we will understand. We also have our VPH line. So now when you go to your display connector, in order for you to test these MIPI lines, okay, now the one thing about the MIPI lines is that the MIPI lines must have the same value. Okay, the difference in the value of each line should not be much. Okay, should not be much. One of the ways to know that this MIPI line is faulty is either when you see an open circuit or a short or a different value that is far different, like it's very different from the rest of the lines. So you know that that particular line is a suspect. Okay, so now you will test this on diode readings to see if these lines are connected, and all of these lines are connected to our CPU. So these lines should not be open. This line should give you value, and if one line is giving you 300 millivolts, that is the value, 300 millivolts, the rest of the line should also give you 300 millivolts. They should not be difference. Or some may give you 298. Okay, it's still okay. Some may give you 301 or 302 value, it's still okay. But if one line gives you 400 or 500 or 150 value, that means that line is suspect. That line is not that line is faulty. So you have to work on that MIPI line. So if one MIPI line is missing, the phone will not display. Okay, so after that, there are other lines that you will test. Okay, and meanwhile, these hardware solutions, they have not shown all the line. Okay, you will not see all the lines here, so you will not have to depend on this hardware solution. You also have to make use of your schematics and your knowledge also. So there are other lines here, but I'm not going to explain these lines with these hardware solutions. I will explain it when we open our schematics. I will take time to explain those lines so that you will understand. Okay, so now if you can see, we have our interrupt line here, we have our voltages line here, enabling line, and also our vreg voltage line. We also have another line here, 1.8 AP VDD. This is still our voltage line. Okay, so let me zoom in. Okay, this is our VDD LCD 1.8 vreg L13A. This is our LDO line. So all of these lines are very important when it comes to display. So I will take time and explain these lines. Okay, and if you check these lines, this line is coming from our power IC. If you follow this line, this voltages line, you know that all of them are coming from our power IC. Some of them from our LDO, and our LDO is coming from our power IC. Okay, like this one. This one is coming from our LDO. Okay, and it is still the power IC that supplies voltage to this LDO. Then the LDO receive enabling power, okay, from CPU to power up this LDO. So now this is an LDO. I will take time to explain this one in our schematics. Okay, so I just open this hardware solution to show us how to test our MIPI lines. So now let's open our schematics. Okay, I've opened our display here, and this is our Samsung S20. Okay, this is our Samsung S20 FE model. So this is the model that we are working on. So this is our display section. If you zoom in, this is our connector. This is our connector, our main to sub connector. Okay, now let me show you the lines that is dealing with display. That is our display lines. Okay, you can see here VDD LCD ELVSS minus 4.4 volts. Okay, these lines are very important. I want to show us our MIPI lines. Okay, this one is our fingerprint. Okay, yes, these are our MIPI lines. The first four of our MIPI lines that we counted on, and on that our hardware solution, this is it. So the remaining 6 lines, okay, this is it. Anyway, you see octa, okay, you know that this is our MIPI lines. Clock, yes, clock data negative and positive. So this is the MIPI lines. So you must ensure that these MIPI lines is giving you the exact value. Okay, the same value. There should be no difference in the value. Even if there's difference, there should be either 2% difference. Okay, so now after testing these MIPI lines, this is where to follow. This is our main to sub connector. You test these lines. Okay, let me show another line. This is our 4.6 volt. See this line, ELVDD. It's connected to 2 pin in this our connector. We also have our interrupt line here. Okay, if you want to test this line, you can combine your schematics and then locate this line, or you count the connector and you'll be reading this line. This interrupt line is going to our CPU, and most of our interrupt line carries 1.8 volts. Okay, so you have to test the connectivity of this interrupt line, if there's an open circuit or not. So it's going from our connector to our CPU. So this is our CPU SM8 250. So this is our CPU. That interrupt line is going straight to our CPU. So it's a function of interrupt line. I'm not going to explain it, but if I want to explain it might take a little time, so I'm not going to explain it in this video. Okay, we have interrupt line. We also have this other line. I've already explained this one. Then we have voltages line, VDD, DD1 3.0, VDD 1.8 AP, and it's not all these voltages line, not all of them have to do with display. So the best thing for us to do now is to locate our display IC and then follow our display lines. Okay, so when you copy this positive voltage 4.6 volts, when you next it will take you to our main display IC. Now this is our main display IC. This is our main display IC. Okay, so now when you zoom in, now you see different lines that are connected with this display IC. You see different lines. So now I've combined these schematics. With our layout so that you'll be able to know the locations of each component. Okay, so now let me zoom in and explain this IC. Please pay attention very well so that you'll be able to understand how this IC works. Now we have our VPH power line here. We have different VPH line that enters this IC. So now our first VPH line is this one, and there are 3 capacitors that are connected in parallel. Now this is ground. This arrow is ground. Okay, this is how Samsung indicate their own grounds. Okay, so now if you want to test, you must first check that this VPH voltage is entering this display IC. So now on this line, you copy this capacitor. When you click it, it will lead you to this place. This is our capacitor. This capacitor that we copied, this is it on our layout. So now you can use your board and then trace and locate this capacitor. Now when you test this capacitor, you get 3.7 to 4.2 volts, and when you connect your charger, that's when you will get this voltage without connecting your battery. Okay, connect your charger, you get this voltage. Now after that, this line continue. Now when it comes, it enters this coil. There's another line that comes out of this line. I will show you that one. Now it enters this coil. Now when you click this coil, it will indicate that this is the coil. You know, I mentioned that there are 3 big coils connected with our display IC. 3 big coils. So this is one of the coil. One of the coil is connected with our VPH line. So this is 10002. Okay, coil. So if you check, this is the same value, L10002. So now this coil, you test each side of the coil, it will give you that voltage. So now this line is connected with this pin number D1E1. That's our switching, LX1. That's our switching. Now the same line comes out and connects to these other lines. Okay, it comes out of here and connect with this capacitor. See, this capacitor is connected to ground. Okay, now there is a coil here. Let me show you. Now there's a coil here. It enters with this capacitor, and this capacitor is connected to ground. Okay, it's connected to ground. When you test this capacitor, you also get your 3.7 to 4.2 volts. And also, if this line is short in your phone, will not turn on. Okay, so now this line enters this IC with this pin number AVIN, and also enters and pass through this coil and enter this other side. Okay, our LX3. So now if you copy this coil, this is the second coil. Okay, you can see that 2 VPH. Okay, you can see that VPH line is connected to 2 coil. Okay, 2 coil. So one coil is responsible for giving us our 4.6 voltage. That's our positive voltage. One coil is responsible for giving us our 7.3 voltage. That's our light voltage. Then the other coil is responsible for giving us our minus 4.6 volts. You see how the thing works. Okay, 3 major voltage: positive, negative, and our light voltage. That our light voltage is 7.3 volts. Okay, so now we are done with this line. Now we are going to move to the next line. That is our VPH line. You must ensure that you get voltage when you connect your charger, okay, on this line. So now after that, we also have another line here, still our VPH line. They are coming from the same source, but they have different lines. Okay, they enter this display IC through different lines. So this is our VPH power, still our VPH line. It has 3 capacitors here connected in parallel. Okay, channel to ground. Okay, so now if you test, you have to test any of these capacitors. If you get your 3.7 to 4.2 volts. When you click on this capacitor, it will lead you to this particular capacitor. This is where the capacitor is located. So when you test this capacitor, you will get your 3.7 to 4.2 voltage. Okay, so now you are done. You follow this line. This line comes in here and goes to this pin PVIN. Okay, PVIN. So now from there it also enters other pins. Okay, it also pass through other pins into this. So now the same line also comes in and enters these other lines. You have to follow this line one after the other. Now if any of these pin is open or is not receiving your VPH power, your display will not show. So when you lift, as you are troubleshooting, when you get to the point that you've not seen the fault, when you lift your display IC, test the connectivity of this VPH line. If all of the lines that enter this IC, if all of the VPH lines that enter this IC are connected, because if one ball or one line is open, one VPH line is not receiving VPH voltage, that means your phone will not display. So this is another line, and this line is our line like LX2. So this line is connected to with this coil. This is our minus 4 volts. This is the coil that generates our minus 4.6 volts, and this coil will be beeping to ground. You see it is connected to ground. I told us that this coil is not shorting. When you see the third coil that is beeping, it should be beeping because it is connected to ground, because it's responsible for generating our negative voltage. So after that, we also have two lines here. These two lines are very important: ES wire, AS wire. Okay, and these two lines have test point. This is test point. So if you click on this test point, it will lead you to this place. So this is where the test point is located. You understand? So now, in case you want to test these two lines, EL on 1, EL on 2, I explained the functions of these lines. So this line is coming from our display connector straight to our display IC. So these two lines are very, very important. These two lines are responsible for turning on for enabling the display IC to generate those minus 4 volts and plus 4 volts, and that's our 7.3 volts. Okay, so if this line is open, our phone will not work. Please go and watch that part 1, so that you will understand these lines, how it works, because I take time to explain this line. So this one, I'm only showing you how to use your schematics to follow. Okay, so now after that, I'm going to show us another line. There are two major lines that is left. The rest of the lines are connected to ground. Okay, the rest of the lines, they are all connected to ground. All right, let me explain this other side. You see 3 LDOs. These are our LDOs, our display LDOs. Now, if any of these LDOs, we have two major LDOs that regulate voltage to our display IC. Okay, so this is our LDO. We have our input, our input pin here. Now, if you copy this LDO, it would indicate where it is located on this layout. So when you copy it, it will show you, zoom in, it will show you where it is located. Okay, so this is our LDO IC. So now we have our input. Okay, wait, let me show you. Let me explain this other line before explaining that LDO. Okay, now we have our ELVDD 4.6 volt. This is our positive voltage, and before this positive voltage is generated, this LDO have to turn on this display IC. So now we have our input line here, input pin 4, and it's coming from our power IC section. So now we have a capacitor in this line. You test to see if this 2.0 volt is coming. If this 2.0 volt is not coming, that means this LDO will not turn on, and our display IC is not going to work. So this LDO is very, very important. Now, if you copy this LDO, it's going to lead you to different sections that this same LDO is linked with. Okay, so when this is our VREG, this is our LDO line from our power IC. So it enters this LDO circuit, this LDO IC. So now, if you keep nexting this line, you will see that it's connected to different lines, to different circuits on the phone, on the phone board. Okay, so now this is where the VREC power is coming from. This is our power IC. Okay, it's coming from our power IC. So this is the line. It comes to this our display IC. So now you must get 2.0 volts on this line. If this 2.0 volt is not entering this LDO will not turn on. So after that, we have our pin number 3, our enabling line, and this enabling line is coming from our CPU. After the LDO receive the 2.0 volts, that's the input volts, now it is our CPU that will enable this LDO to work. So now if this line is open, if this line is not connected with our CPU will not be able to activate this LDO, and this LDO will not work. And this enabling line will carry 1.8 volts, and the 1.8 volts is coming from our power IC also. So if that line that give 1.8 volts to this our enabling line is open, still our phone will not work. Okay, so if you check this enabling line very well, it's coming from our CPU. So you must ensure that this line is connected. Okay, and you can test it that you see those pins outside that this LDO IC. So after we have our ground here and also our output. So now it is this after the LDO receive the input voltage from power IC, and then the CPU enables it through this enabling line, that it will create this VDD LCD 1.8. I showed up this line on our connector. So this is where this line is coming from, this LDO. This line, this output line is very, very important. If this 1.8 is not entering this connector, our display IC will not activate. Okay, so this is the VDD LCD 1.8 volt, and it has a capacitor that is connected in parallel. So test this capacitor. If this VDD LCD is connected, okay, if you get that voltage on this connector, on that capacitor, you know that the voltage is creating. Okay, if you do not get these voltages, this VDD voltage, go and work on your LDO circuit, this LDO IC. Okay, so now after that, when this 1.8 volts enter that display IC, that display connector, it will then join with this it will join and connect with this ELON1. Okay, now I explain how it works on our diagram. That's our part 1 of this video. So if you watch part 1, if you've watched part 1, you will understand how it works. Okay, so we have another line here, another voltage line, still our second LDO. The same way you troubleshoot your first LDO, the same way you troubleshoot your second LDO. Our second LDO will enable this EL on 1. So now this our VDD will enable this EL on 1, and our second LDO will enable this EL on 2. Okay, so now when these two line EL on 1, EL on 2 comes, it will activate this display IC. Okay, and then our display IC will generate our positive voltage and our light voltage. When I mean light voltage, is that 7.3 to 7.6 voltage. Then our positive voltage is our plus 4.6 voltage. Okay, so this is the function of these two lines, and these two lines can only activate this display IC after when that LDO might have turned on. That is when these two lines will work. Okay, so now the first line EL on 1 will activate this line EL VDD 4.6 volts. It will activate it. Okay, it's the VPH that supply the voltage. Okay, but it is this EL on 1 that activate this line to work. Okay, now our EL on 2 will activate our 7.3 voltage. Okay, that's how it works. Let me show us. So now when our EL on 1 activate this line, this 4.6 line, okay, it will activate this 4.6 line, and this line will generate voltage. Okay, now if our EL on is not sending that 1.8 volt to this IC, this line will not turn on. Okay, this line will not turn on. I will take time and show us how to apply that trick, so that you, without connecting your screen, you will know if this line is creating. So you can copy this capacitor and test if this 4.6 voltage is creating. And this 4.6 voltage can only create this voltage after you've connected your clip. Please take note, you have to connect your screen before this ELVDD 4.6 will generate voltage. This is the coil. There's a little coil that is connected in between on this line. If this coil is open, you will get voltage on one side and voltage will not reach the other side. So these are the things you have to check. And this ELVDD 4.6 volt can only generate this voltage if this EL on 1 give that 1.8 voltage to your display IC. Okay, and that EL on 1 can only give that 1.8 volts after you've connected your screen. So now that 4.6 will come to this connector, and it will come to this connector, and then it will meet with your screen. Okay, so that is where the miracle happened. When it meets with your screen, then your screen will display. So now we also have this second one, EL on 2. Now this EL on 2, you have to check this test point if you get your 1.8 volts. Before you get your 1.8 volts, you must connect your screen. Without connecting your screen, you will not get this voltage, this EL on 2 voltage. So that this EL on 2 voltage will turn on this our 7.3 voltage. It will activate this voltage. This is our light voltage. You can copy this coil that's on this line and check. If this coil is open, this line will not work. Okay, the voltage will not get to the other side. So you have to check this coil. If it is open, you replace it with another coil. Okay, so now when you copy this ELAVDD, this is our light voltage. I told us that the voltage we get on our normal display, that's 16 to 40 volts. This is the same voltage. We will get that same voltage here, but this one will be 7.3. So when you copy it, it's going to come to our screen connector. This is where this voltage is coming from our display to our screen connector. Okay, please do well to watch this video again and again, and also watch part 1 again and again, so that you'll be able to understand. Don't expect to understand after watching it once. Okay, no, you have to watch it again, but there are a lot of things that you will understand after watching it the third time. Okay, so now this voltage will go to our connector. Now we are done with this voltage. Please understand the logic. It is only after the EL on 1 is turned on, like it supplied that 1.8 volt to this IC. That is when these voltages will turn on. And that EL on can only turn on when you connect your screen. So we also have this coil. If you remove this coil that is shorting to ground, thinking that it's shorting, if you remove this coil, your minus 4.6 voltage will not generate. Okay, this coil that is connected to ground, it is responsible for creating this minus 4.4 volt. So you also have to test this coil that is connected on this line. If this coil is also open, replace it. Okay, replace it. So now this is our negative voltage, minus 4.4 volts. Okay, so ensure that this voltage is also creating. If this negative voltage is not creating, your phone will not display. Okay, so if you don't get another a coil to replace, you can jumper this coil. Okay, you can jumper this little coil. So now when you copy this voltage, it comes and connects to two pins on this our screen connector. Okay, it connects to two pins on this our screen connector. So now I've taken time to explain how to troubleshoot this display circuit using your schematics. Okay, so now if you want to know more about phone repairs, please subscribe to our channel, and also do well to join our online training. We have online training course that is ongoing. Okay, so when you join our online training course, you will learn a lot. Okay, so now I promise to show us a trick for you to be able to know which one is faulty. Is it the LDO section is faulty, or it is the display IC that is faulty? Okay, so now I explained that you see this EL on 1, EL on 2. Now you can, these two lines receive 1.8 volts after connecting your screen. Now you can give 1.8 volts from your DC supply to this test point EL on 1. All you need to do is just connect your charger. Don't connect your screen, don't turn on the phone. Okay, just connect your charger. Don't connect the battery, only your charger. Now when you jumper 1.8 volts, that's when you give 1.8 volts from your DC supply to this EL on 1, to this test point, then you go and test this positive volt, this plus 4.6 volt on your meter. If you get that voltage, you know that your display IC is okay. On that side is okay. That means the fault might be from the connector or from the LDO, because it is the connector and the LDO that should give 1.8 volt to this line. So now you just you bypass that voltage and give 1.8 volts from your DC supply to this test point. Now you test this capacitor. This is our ELVDD line. You test this capacitor if you will get this 4.6 volts. If you get this 4.6 volts, you know that this IC section that is responsible for creating this voltage is okay. Okay, that means that you have to work on your LDO. So now that is the trick. Without wasting much time, just give 1.8 volts from your DC supply to that EL on 1, the test point of it. Then after that, you connect your charger. You have to connect your charger, give that 1.8. Okay, then you test this line to see if you get this 4.6 volt. And when you are when you are doing that jumper, make sure that your charger is not connected. After you've done the jumper, you connect your charger and then you turn on your DC supply. Okay, so now the next one is that you after checking that positive voltage, you also remove that wire. That your jumper wire, and connect to this other EL on 2 test point. Okay, let me explain again so that you understand. I said that when you connect your connect your wire to this EL on 1, you will test the other voltage. It should be giving you 4.6 voltage. So after that, you remove that wire and you jump it to this other test point on this our EL on 2, because you want to check another line. When you give that 1.8 volt, you connect your charger, you turn on your DC supply, then you will take voltage on this line. This is our 7.3 voltage. You check this capacitor. Okay, if you will get this voltage, that means that this other line is also okay. But if you don't get voltage, that means that it is this IC or this line that is faulty. It's simple. If you don't get the voltage, know that this line or this IC is faulty. Work on that line. Test those components, or replace the IC or reball it. But if you get the voltage, you know that it is either the connector or the LDO that is not giving that 1.8 volt that you've bypassed. Okay, so now the other coil that is beeping to ground is the one to give that minus 4.6 voltage. So if it is not creating, after giving the 1.8 volts, you know that all the voltages are generating. So you have to test these LDOs, because maybe the LDO is not giving that 1.8 volt. That is why those voltages were not creating. So now after you bypass it and give that 1.8 volt, you see that those voltages are creating. That means that the IC is okay, is to work on the display LDO. Okay, thank you for watching this video to the end. Please remember to subscribe to my channel, comment and like, so that I will be motivated to keep posting educative videos like this. All right, thank you. See you in my next video.